Okay guys, today we're going to be talking about spheres. A sphere is a 3D version of a circle, like a ball, a water balloon, a globe, anything that is circular 3D. You can catch it, throw it, things like that. So sphere is shaped like a ball. Volume. Volume is filling up that ball. Okay, so how much it would take to fill it. So examples of volume would be filling a water balloon, filling a basketball with air, the earth, whatever it's filled with, the dirt, the core, all the stuff inside. It's the filling up, it's the inside of it. The surface area is how much it would take to cover it. So if you're talking about the earth, how much would it take to cover it in water, grass, trees, things like that. Painting a globe or any kind of ball, that is surface area. If you give someone a basketball for their birthday and you want to wrap it, how much it takes to wrap it is the surface area. There are two different formulas for these, one for volume and one for surface area. I will tell you that these are probably the most complex formulas that we've done. You're going to need a calculator that you can get fractions into, that you can get things to the third power. So if you don't have one, you're going to want to download some type of graphing scientific calculator onto your iPad. These formulas you will find on the formula sheet that I downloaded a while back, but I'm going to write them here as well. So the formula for surface area is 4 times pi times r squared. The volume of a sphere formula is way more complex. That's 4/3 times pi times the radius to the third power. Okay, so you're definitely going to want to have those written down somewhere. Okay, oh, sorry, my dogs are fighting. Okay, in this first one, you can see that the radius is 10 on this one. So your radius is 10. My dog also sounds like Chewbacca, fun fact. All right, so the radius is 10 for this one. So for the surface area, remember the formula is 4 times pi times the radius squared. So the only thing that we have to do for this one is substitute in what the radius is, and in this case it is 10. So 4 times pi times 10 squared. So when you stick that all into your calculator, you would get 1,256.63. You will notice that for these problems, nothing is a number, a regular old number. They're all going to be some really funky decimals, okay? So if that radius, let's say that was a ball with a 10-inch radius, it would take 1,256.63 square inches to cover the basketball. Now this might not seem like something that you'd ever need to know if you were wrapping one. You're not going to measure out square inches. But if you worked in something like packaging, you would need to know that, because if you're working in packaging, you want the least amount of cardboard or something that it would take to cover it to save your company money. That's how you would end up using this. Then we'll go to volume. So for volume, we're going to use that formula of 4/3 times pi times radius to the third power. So now volume, you'd need it if you were making something where you had to fill something up and you needed to know how much it was going to take, how much liquid you were going to need, how much air you were going to need, how much helium, if it's a balloon that you're going to need. Okay, so again, all you're going to do is replace this r with our radius. So we're going to do 4/3 times pi times 10 to the third power. Now remember, if you're using a graphing calculator like we have in class, that 4/3 should go into parentheses, and probably on some of the ones you have online too that you have downloaded. So what you should get when you put that into your calculator is 4,188.79. So again, if you're talking inches here, this is how many cubic inches it would take to fill it. Now a cubic inch is, think of an inch and then make it into a cube. So 1 by 1 by 1 by 1. Or if it was centimeters, think of something like a sugar cube the little ones that you put in coffee or you feed to your horse or something like that, that's a cubic centimeter. Okay, so that's what we're talking when we fill it. We're talking about cubic inches, cubic feet, cubic centimeters. Where you would use cubic feet and stuff like that, not necessarily in a sphere, but if you're talking about buying loads of wood chips or stone, something like that, those are measured in cubic feet when you buy them from a landscaping supply store. So you do kind of need to know what those terms mean out in the real world. Okay, and the next one you can see our radius here is shown. It is 21. So remember, radius is from center to outside, so our R equals 21. So for our surface area, that means that we're going to do 4 times pi times 21 to the second power. And when you type that into your calculator, you should get 5,541.76. For the volume, you're going to do 4/3 times pi times the radius, which is 21 to the third power. When you type that into the calculator, you should get 38,792.38. Okay, this one's different from the other ones because I don't have a radius. I have a diameter. Remember, diameter is the full length across, and that is what I'm given in this problem. I'm given the full length across. Now, my picture is not great, so just pretend like that goes through the middle. So if that is my full length across, what I need to find out is the radius, which is half that length. So I'm going to take 34 and I'm going to divide it by 2 to find half of it. And that will give me 17. So my radius in these problems is 17. So whenever you're given the diameter, just do that formula we learned last week and divide it by 2. Okay, so now that I do that, I can go on and I can find out my surface area. So I'm going to do 4 times pi times 17 squared, and that will give me 3,631.68. Then to find my volume, I'm going to do 4/3 times pi times my radius to the third power this time. And when I push that in the calculator, I should get 20,579.52. Okay, and this last one, you're also given the diameter. So you can't use diameter in these formulas. You have to use radius, which means that we have to find just this distance from the middle to the outside. So I'm going to take 110, divide it in half, so divide it by 2, and it's 55. So that means that my radius for these problems is going to equal 55. So for my surface area, 4 times pi times 55 squared. In the calculator, that should have given you 38,013.27. Then I will do my volume, 4/3 times pi times my radius to the third power. And when you push that in, you should get 696,909.97. Obviously, 110 feet across or inches is a pretty big ball, pretty big sphere. You're looking at like the world's largest rubber band ball or something goofy like that when you are seeing something that big. But obviously, if you're talking about the Earth or a planet, it's going to be giant numbers like that. You will have some homework. I will attach that to the lesson as well. Have a great day.